Hello everyone, today is day 35 of solving a LeetCode problem every day, and today we're going to be solving same binary tree. So given the roots of two binary trees, P and Q, return true if the trees are equivalent, otherwise return false. Two binary trees are considered equivalent if they share the exact same structure in the nodes and have the same value. So we have these two trees here, and these trees are equivalent because we have 1 as both of the root nodes, then 2 as both of the left children of the root nodes, and 3 as the right children of the root nodes. Now in this case, we're going to have false, and the reason why is we do have 4 for both of the root nodes, but the 7 is here on the left child, but the 7 is here on the right child. So the left child do not equal each other in these trees, and the right child do not equal each other in these trees either. So these trees are not the same. Now with this output, it's pretty much the same idea as this one. These children are flipped, so the trees are not the same. So basically, if we were to break this problem down into smaller pieces, what we essentially are trying to do is find a way to traverse the entire tree, but also while we traverse this entire tree, we need to make sure that these nodes are equal for both of these trees. So I think the easiest way to traverse this tree is going to be by doing it recursively. We're going to break this problem down into smaller pieces, and we're going to start checking for equality from I guess the very end. It's going to make more sense in a second when I start writing the code. But for starters, we're going to have to define a base case, and that's going to be if P is none and Q is none. And in this case, we want to return true. So basically, we would hit this case if at some point we traverse, and so we have our P node here and our Q node. And at some point, let's say if we go to the 7's, or let's see, at this 2's left child right here, we'd go to none. And the same thing would happen on this tree. It would go to none. So in this case, we can just return true because we've gotten to this point and P and Q are both none. So we can return true because those two nodes are equivalent in a sense. But the other case would be that if P and Q do exist and the values of both of them are equal, so the value of the P node and Q node are both equal, what we're going to do is recursively call this same method on the left nodes, but then we're also going to want to do them on the right nodes. So what we're going to do here is, let's say we're starting at P and Q where they're both equal to 1. Neither of them are none, but they do exist and their values are equal to each other. So we're going to call the same method twice, once on the left children of each node and once on the right children on each node. And then at some point, these are either going to return true or false. It's going to return false in the case that that neither of these are true. So if neither of them are none and the two nodes don't equal to each other, then we return false. And then we have an and over here. So basically, if either one of these are false, false is just going to be returned. Because remember, with and, the only way to get true is if you have true and true. So if you had true and false, false would just be returned. So that's the reason why we're using and here. So if I run this, we do get the accepts if I submit this too. So yeah, so this is going to run in linear time complexity, and the reason why is that we're just processing each node just once, we're traversing each node once, and then the space complexity is constant. Um, but yeah, I hope the solution makes sense. So generally, what the idea is uh we keep recursively calling the same method on smaller parts of the trees, and we basically ensure that these smaller parts of the trees are equal. And then once we do that, we start traversing back up and making sure that these bigger trees are essentially equal. So yeah, I hope that makes sense.